So with that, there doesn't seem to be any questions. Let's get right into it. I'm going to cover production of carrots, a little bit of scouting techniques overview, and then I'll hand it off to Travis also to cover some production of celery. So it's good to give a background of the crops. I think it's important, especially when it comes to the family that the crops are in, because it gives a lot of context in terms of pests that the crops are going to deal with. So carrots specifically are part of the Apiaceae family. They also in this family are parsnips, parsley, celery, and dill. So this family used to be called the umbelliferous family as well. So umbels are the root word that it shares with umbrellas. And you can see sort of that third picture there, that typical Queen Anne's lace sort of flower, sort of that dome-shaped flower that kind of looks like an umbrella. That's where this family's name comes from. So all these flowering plants have that similar flower structure. A lot of these plants are biennial. So they actually just flower the second year and not the first year. In terms of harvested area in Ontario, we have carrot acres is held pretty steady. We're just over 8,000 acres a year in Ontario, and that's all types of carrots produced, so fresh market, baby carrots, and processing. If you look at celery, celery is also held steady, a slight incline, just over 600 acres per year. So last year, 2019, we had around 700 acres, so a slight uptick. A lot of that may have been related to that celery juice cleanse. There was a higher demand at the beginning of last year, and the market responded accordingly. If we're looking at the cost per pound of these crops, carrots held pretty steady over the last number of years. Their price per pound has remained relatively steady. Onions on a slight increase, and celery you see there for a number of years is on the incline. So whether that's related to recent health crazes and diets, but the price for celery has started to increase. If we look at where carrots are mainly produced in Ontario, there's sort of hot pockets of intensive growing areas. So you see that in the middle of the map, the Simcoe York region areas, a large part of our muck growing regions are in that area, in sort of the Lake Simcoe area, the Holland Marsh and surrounding marshes. That's probably around half of our provincial carrot production is in those two counties there. We have a little bit out eastern Ontario, and we also have more processing carrots grown on mineral soils down in the southwestern part of the province. So about half of our carrots are grown on mineral soils, half on muck. So a large part of those mineral soil carrots are grown in that Lambton, Kent, Middlesex, Essex sort of region. Getting into how carrots are actually produced, I mentioned earlier that most of the Apiaceae family are biennial crops, which means they'll grow the first year, store some sort of root or storage, so that the second year, after they had a cold tolerance, they will flower and then reproduce from there. So we're growing most of these crops in their first year, right? We want that harvested portion of the root or the crop that we are going to market. Most carrots are produced in some sort of raised bed structure. So carrots need to have good drainage. They don't like having overly wet soil. They like to grow a long, straight taproot. So, and growers have different combinations of beds, but in general, they're all grown on some sort of bed or hill structure. So this is some of the row spacing or the beds you may see, right? So in general, beds are at least sort of 6 to 8 inches tall, 15 to 20 centimeters. The row spacing will depend on the grower, and that's sort of standard to each grower. In general, they'll be around 28 to 36 inches across. You can also see on the left that some carrots, especially processing carrots, are grown more of on a raised bed structure, more similar to something like onions, where they'll have one or multiple rows of carrots grown on that single raised bed. But the principle is the same, is that you want that carrot up off the ground so that it has adequate drainage. This is what carrots typically look like, right? So you'll have 3 or 4 lines on a bed. So if you can see here, all those carrot lines are growing, they're emerged, and they have those true leaves starting to form. On the left there, on the left part of that raised bed, you see some what looks like grasses. So that's actually what we call a wind abatement crop. This nurse crop will germinate early, quicker than the carrots. Carrots are notoriously slow germinators, and they will provide some protection for those really sensitive and delicate cotyledon stage, bunny ear, early carrots. So protect them from any wind or sandblasting early on in the season. Later on, growers will spray a herbicide, a grass herbicide, and selectively kill off that nurse crop. Some growers will also broadcast that nurse crop so it comes up across the whole field and they'll spray that off later. Growers have their own way of doing things, but in general, a lot of the carrots, especially early, will have that wind abatement crop to protect the early germinating carrots. Talk a little bit about the growth stages because it's very important for scouting to report back to the grower what the growth stages of the crop are. This has a lot to do with timing, herbicide timing, insecticide timing. So it's really important that you know what the different stages of the carrot is called. The first stage that emerges is the cotyledon stage, and we call that the bunny ear stage. So you see there the bottom left, and the middle picture sort of looks like a cute little bunny ears popping up out of the ground. That's what we refer to as the bunny ear stage. From there, you can start to see in that second picture that true leaf starting to form and kind of come out. And from there on the right, that's a carrot probably in the second to third true leaf stage. That's when the real carrot, typical carrot leaves start to grow. So from there, you can count the first, second, third true leaf and report back to the grower with those leaf stages. Once we get to around the 6th leaf stage, we stop to report leaf stages in carrots and we go more to a crop height or a canopy closure sort of growth stage. So I'll take you through the life cycle here. You see the top left, those bunny ears popping up out of the ground, recently germinated. That second picture to the right, you see that first true leaf starting to form and curl out from in between those bunny ears. And then at the bottom left, you see sort of that's when you start to transition from counting growth stages and leaf stages to responding back sort of canopy closure. So we like to report back canopy closure because it's important. A lot of growers like to apply a fungicide right before the canopy closes, because you can see at that bottom right, once that canopy closes, there's really no sunlight allowed to get through there, and it also traps a lot of moisture. So that leads to some potential diseases developing down underneath the canopy because the leaves stay wet for much longer. So a lot of times growers like to apply a fungicide before the canopy closes, so it's good to report back the canopy stages. Weed control is critical in carrots. You see there is a carrot crop somewhere underneath all those pigweed that are growing. Carrots are really reliant on groups 5 and 7 herbicides, and there is a quite widespread population of group 5 and 7 resistant pigweed across the province. So growers have a tough time, especially dealing with pigweed in most muck growing areas, but also lamb's quarters, any other amaranth species, and resistant grasses are very common. Kind of depends on where you are, but so it's really important that you know your different weeds and be able to identify that and report that back to the grower. Weed controls are carrots are very sensitive to weeds, especially early on in the growing season. This is the critical weed feed period. This research was developed by Clarence Swanton out of the University of Guelph, where early seeded carrots can take up to the 12th leaf stage, where any sort of significant weed competition will result in a decrease in yield. So that is a very long time where you have to keep the carrots weed free. Later seeded carrots can sort of get up to the fourth leaf stage, that critical weed feed period. But it highlights the importance of keeping that carrot crop free from weeds because it has a huge impact on yield. Almost all the carrots across the province will have at least one hand weeding required in the field, and some multiple times. Carrots are generally harvested by a machine that uses belts to squeeze the tops and a shovel to go underneath and sort of dig them and pull them up out of the ground. That's sort of the general idea. There are some harvesters that, especially in the processing side, where they will top the tops off the carrot and they will dig them, sort of like a root crop harvester or a potato harvester. Will just sort of dig those carrots out of the ground. But I would say the majority is harvested this way, where the machine is used and belts are used to pull them up out of the ground by the leaves. So just a quick video to show one of these harvesters in action. You'll see those points there that are gathering the tops. It squeezes it in between two belts. Those belts lift the carrots up out of the ground. They'll go up top there where spinning knives will cut the tops off. The carrots will drop down and they'll load those into a trailer full of general boxes or just a big dump trailer where they can go into either storage or into the pack line. I mentioned before that carrots can also be dug out of the ground. This is an example of that, where it's actually a potato harvester, where they dig the carrots, remove the tops, dig the carrots out of the ground, shake the dirt off them, and then they'll go into either boxes or a big bulk trailer that they can dump. Carrots are generally stored in cold storage. They are stored in wooden pallet boxes, but they can also be stored in big piles in bulk storages. Some jumbo and processing carrots can be stored all the way up to around June or July, but generally a lot of the fresh market cello varieties that you'll see like in a bag at the grocery store are only held until around April. At that point, they lose too much moisture and they become too limp and they lose too much yield. But those larger carrots that go into processing or dicing or slicing can be stored much longer. In some of the warmer parts of the province, there's also an ability to store carrots over the winter by insulating them in the soil so that they don't freeze. So this is a practice that's used across the ocean in UK very often in sort of those temperate climates where it doesn't get too cold in the winter, and some of the warmer parts of our province can also do this. So basically they'll cover it with 1 to 4 feet of hay and straw to keep that crop insulated, and then they can harvest that the next year. That's it for celery. I'll hand the floor back over to Travis.
Right on. Thanks, Dennis. Yeah, we'll get started with a little bit of celery production and then followed by a few slides about scouting in general. So celery is grown for fresh market and for processing. There's a few acres of celeriac grown in Ontario. It just looks like celery, only it has a bulb-like stem or hypocotyl, can be eaten raw or cooked. With both of these crops, they're grown from transplants if the weather is favorable, and it is typically harvested 8 weeks after transplanting. So multiple seeding dates allow growers to continually supply processors or stores from late July to as late as October. Bottom right is celery grown in mineral soil, but a lot of celery is produced in muck soil. Just like in carrots, weed control in celery is difficult. Most of the herbicides that are registered require a hooded sprayer. Often multivators are used to control weeds between the rows, and weeds between plants are removed by hand. Besides weed control, irrigation during dry periods is critical for obtaining a good yield. Celery harvests depend on its end use. So for fresh celery, it's cut, trimmed, and might even be boxed in the field, while processing allows a harvester to basically dig up that celery or cut that celery the same way that you saw those carrot harvesters earlier, and then cut it into sections with rotating knives in the field. So here's a celery harvester for processing celery. So it's going up those belts into a conveyor. There's knives spaced 4 to 5 inches apart, cutting it into sections, and then the leaves and any smaller, lighter bits are blown out. All right, why scout? Let's get into some pests and diseases. So why are we scouting? We're trying to monitor pest populations, maintain plant health, and produce quality yield. IPM is approach, integrated pest management is an approach to pest control that considers all management options to maintain pests below an economic injury level. And it is done primarily by identifying insects or pests correctly and applying the proper management strategies. So scouting 1 week is ideal. Twice is preferable. It's a good idea to keep a field map and note questionable plants each week, mark them down on the map. To be thorough, record the date, crop stage, any pathogens or pests during each visit. Ensure that your vehicle is stocked with supplies that make monitoring easy. A few that I would like to highlight is a trowel or shovel. They're really important to have a trowel so that when you're pulling out a plant, you get those fibrous small roots and you're able to see the roots as well. Wired flags that might be used for, if a hydro company or gas company is surveying. Those flags make it easy to come back to the same place in the field and check on those plants a week later. And Ziploc bags are very handy to have just so that they're easy to keep in your back pocket. You pull them out, put the suspicious plant sample in that Ziploc bag. It's sealed, it's not going anywhere, and you're potentially not spreading spores throughout the field as you move around. As well as you would want to keep a pest or pathogen calendar, like the ones here for carrot and one for celery. So when you're going around scouting, you want to choose 5 sites that differ as much as possible. Maybe one in a high spot in the field, one in a low spot where there might have been flooding earlier in the season. If there's a greenhouse or windbreak, this might be a good place to monitor because it could be a refuge for insects with that microclimate there. And it would also be good to check out along sprayer rows or at a field border. Scouting insect pests of these crops allows us to determine if you are above or below a given threshold and whether it is economically worth managing the pest. Some insects can be left in low numbers without compromising the overall crop quality. When there are no thresholds present, the grower must make decisions to whether to apply the pest product. Most cases, especially with fungi, no lesions are acceptable and therefore the threshold is close to, if not 0. Word about personal exposure, and as a scout or consultant, you have no control over the product toxicity, no control over the product pesticide used, so you are in control of your exposure by the time you spend in that field and the personal protective equipment that you have. Communication is key. Talk to whoever is in charge of spraying the field. Always follow the REI on the label. The most up-to-date labels can be found on the Health Canada website. So just Google PMRI label search, and this Health Canada PMRI page could come up. Enter in the pest control product in the search bar there, and bring up the most up-to-date label. We also have a summary of the registered insecticides and fungicides, can be found in Pub 838, and the registered herbicides in Pub 75B. But labels change, new labels come out, and if in doubt, always refer to the Health Canada website. If you're applying chemicals, make sure that your pesticide license is up to date. And a quick word about biosecurity. Be mindful about how easily pathogens can spread. 1 gram of soil can have thousands of spores, and all you need is a few spores to come into contact with another plant at another field, and you're just spreading one field's problems to another. So clean off all dirt, or as much as possible, from equipment, from your boots, from tires. And if you see anything that you can ID, send samples for confirmation, just so that you know exactly what you're dealing with. And with that, if you have any questions, feel free to put them in the chat. We'll review them over the break. Thank you.
All right, great. Thanks, everyone. We'll follow up at the end of the training. And hopefully by then our answers will have improved a little bit, and we'll go over the answers as well. But we're going to cover sort of carrot and celery insect pests right now, and sort of give the overview so that you can feel prepared to scout some of these fields. So we're going to go over sort of what to look for, what sort of trapping methods you can use, and what those thresholds are for all of those pests. So just a quick refresh of what thresholds are, because we'll be talking a lot about that in this section. Economic or action threshold that growers use is basically a guideline for action. So what that means is if you have 5, let's just say insects. If you have 5 insects in your field, is it worth it to go and spray insecticides to kill those insects? Probably not, right? Maybe in some cases, but probably not. Well, if you have 50 insects in the field, is it worth it for a grower to spray insecticide? I don't know. Is it if you have 200, if you have 300, if you have 500? What is the level of insects in the field where it is worth it for the grower then to make a management practice based on those numbers? So that is a key part of the scout's job, is to accurately report back what is actually going on in the field. What are those numbers? If you are overestimating what the populations are, or if you're underestimating the populations, that has effects on what management strategies the grower is going to employ based on these management thresholds that have been developed through research a lot of times and through vigorous testing. One thing that might be changing is that a lot of the old pesticides like OPs and pyrethroids, they have a broad spectrum action. So that makes them kind of nasty to work with generally, right? They're quite toxic. They kill a whole wide range of insects, good and bad. And some of the reduced risk new pesticides have more specific spectrum. So they don't kill a wide range. They may just kill 1 or 2 insects or a specific type of insect. They also may take more time to work, which means that our thresholds might have to be adjusted a little bit depending on which product the grower is using. If our product needs a couple days in order to be effective, then we may have a lower threshold so that the grower can apply the product before the pests get to above that threshold where that product isn't going to work. Just some things to keep in mind. This is if it pops up anytime now. There we go. This is a sort of a diagram of a spray threshold based on, in this example, is carrot rust fly. So carrot rust fly is, I'll mention in a couple of slides, is monitored using sticky cards, and it's sort of an active threshold. So every time you scout again, it's the counts from the last time you were scouting. So we use those counts to monitor when the peaks are, and then whether or not they go over the action spray threshold. So in this case, 0.1 spray threshold would have been reached middle of June, and then again, kind of late August. So let's get into some insects. In Ontario, generally, the type of insect and the main insect pest is going to vary based on where you are in the province and based on whether you're on mineral or muck soil. But in general, the three main primary pests you're going to encounter are carrot rustfly, carrot weevil, and aster leafhoppers. Those are sort of the three perennial pests and the ones that typically do the most damage. Sort of secondary pests are wireworm, millipedes, and cutworms. Wireworms could be moved up to a primary pest in some regions. It really just depends on your cropping systems, and it's really field specific, but they can also do a huge amount of damage. So first one I'm going to start with is the carrot weevil. So this is a weevil. So sort of in the beetle family. Adults are sort of brown with kind of black blotches on them. They have a cute little snout there, or some people may refer to them as cute. Around 6 millimeters long, and the larvae they produce are sort of a yellow cream, and they have a brown head. I'll talk more about that on the next slide, but just keep that in mind. Historically in Ontario, we've had one generation per year. That seems to be shifting a little bit as either we're having sort of warmer growing seasons, or sometimes our winters aren't as harsh, but we may start to see two generations as well, which adds another layer of management problems that researchers are working on right now. But in general, you see one generation per year. So that means adults are overwintering in nearby grasses or ditches or some protected area, and sometimes even in the field. From the last carrot field, they will emerge sometime in the spring and early summer. They will infect the crop. Those larvae will feed, they'll become adults, and they will overwinter into the next year. So the peak timing right here is peak oviposition. So that's the egg laying. So that's when the females, adult females, are walking around and they're actually laying their eggs. So that's the high risk time. That's typically historically from mid-May to early June. Again, that may be shifting a little bit depending on your area, but that's historically when the risk timing really is. So I mentioned that overwintering adults and the females emerge from plant debris. So they could potentially fly, but haven't been extensively documented. So we assume that carrot weevils are walking from field to field. So carrot fields from the previous year that have had carrot weevil damage, we assume that the carrot weevil adults will be overwintering either near those fields or in those fields. And in the spring, they will walk and they will try and basically sniff out the next host field. So celery is also a host, parsley is also a host. Basically anything in the umbelliferous Apiaceae family is also a host for this. So they will walk around until they find some sort of host plant so that they can lay their eggs for the next year. The female will chew small little holes in the petiole or the crown of the carrot and lay their eggs in there and then sort of cover it. And the real damaging part, so the adults can feed a little bit on carrots, but that's not really does the damage. It's really the larvae that are feeding and doing the huge amount of damage. So these larvae, they hatch from their eggs, they tunnel around the carrot, and they create some unmarketable feeding holes. So what's diagnostic about carrot weevil damage is that they have basically open cavity tunnels. So that's how you're going to kind of differentiate them from other insect pests that maybe have, or other feeding damage, is that they're typically at the top third of the root and that they are typically winding but open feeding cavities. I'll show you some other types of damage you see here. So see those windings starting from the top where those eggs were laid. They sort of tunnel around, open big cavities. Those start to stretch at the top right when the carrot starts to grow, and they become bigger and uglier. You see the bottom left there? That's actually an egg laid in a carrot. So that female opened a little hole in that young carrot and laid that egg, covered it up. So that carrot will likely die once that egg hatches and the larvae will feed. And that's what happened at the bottom. Right there, you see that all the feeding damage on the taproot. Basically, it had 1 or 2 larvae totally tunnel through the carrot, and that carrot has now died. We can predict when the carrot weevils are going to be most active and most active laying eggs based on a studied degree day model. So this model is based on base 7 degrees. Basically, what that means is that you take the average daily temperature, and any degree days over an average of 7 will accumulate degree days. So that means that anytime the average temperature is over 7 degrees, carrot weevils are likely progressing in their development. We start that accumulation on April 1st, and it is useful to predict egg laying activity. So that oviposition period of the females, it's useful to predict when the adults in the field are actually laying eggs and when it's at most risk for the crop. So the first oviposition is expected at 147 degree days, and an important threshold historically has been the 90% oviposition expected by 455. So basically, at that time, we expect that the majority of the females have already laid all their eggs, and a later seeded carrot field that is seeded after this threshold will not be subject to high amounts of carrot weevil damage due to the fact that the females have already all laid their eggs. So that's an important threshold. All this information we include on our weekly vegetable crop report that's posted on our On Vegetables blog. So we have a couple different weather stations across the province that we use, and we'll report back to that once a week. So whatever region you're scouting in, you can check that report and see sort of where those thresholds are at. If you just subscribe to that blog, you'll get kind of an email, just emailed to you. So how do we actually find out what's in the field? Well, we use bait methods. So we can use bait stations, which is basically carrots that you have from last year. You put them around the field, and we put them at the edge of the field, right? Because as I mentioned, the adults are overwintering in protected areas, which are usually outside of the field, and then they'll walk into it. So you want to catch them as they're walking from outside to inside the field. So you place these bait carrots at the perimeter, and ideally before the first true leaf stage. So ideally, we like to get them out at the beginning of March, so that we can catch as many carrot weevils as possible to get a real representation of what the actual pressure is. Because if you put them out too late, the carrot weevils have already walked into the field, and you won't catch them once the crop is actually emerged and up. So one really common way of monitoring, there it goes, is a boy-ven trap. So this is basically a bait carrot in between 2 pieces of wood, and then you see these sort of wooden slats there. That gives a perfect home for the carrot weevil to just kind of hang out. So they're attracted to the trap by the carrot, and they hang out and stay for you to count them because of those wooden slats give them a nice home. So it's a perfect way to get a good idea and representation of what are the carrot weevils in the area, how many are there, and are we at threshold? I will just mention quickly as well, you can see on this carrot, that's actually the oviposition pits. So that's on the bottom left there, you see some of those holes and divots. That is actually all the adults feeding on that actual carrot and getting ready to lay eggs inside of it. This is what the traps sort of look like. So typically we put them in pairs. So you'll have 2 traps, and a lot of times sort of 2 different spots will do. So 4 traps kind of put at the perimeter near ditches or near grasses or near a barn, that kind of idea. That's the spot where you put them. Some larger fields you can have up to 6 traps as well. So I mentioned we do have a threshold for carrot weevil. So I'll walk you through how to make those calculations. So in this case, we're assuming it's a large field and we have 6 traps. And let's say we scouted the field on May 5th, 8th, 12th, 15th, and 18th. So on the first day, May 5th, you didn't find any weevils. Okay, your cumulative count is 0. On May 8th, you find 6 weevils. Okay, so we take the weevils per trap number. So you had 6 traps, 6 weevils. It's 1. Your cumulative weevil count is now 1. So we use that cumulative count. It's different than what we typically use for flying insects, which is more of an active day-by-day count. the carrot weevil is going to be a cumulative risk threshold. So you come back on May 12th, you find another 6, that's another 1. Now you're at 2, you add it to the 1, you're at 2 cumulative. You find 12, that's another 2, that's 4. So you get the picture. So what do those numbers mean? Well, the spray threshold for carrot weevil is 1.5 cumulative weevil traps at the second leaf stage. So what that means is that if your field has accumulated more than 1.5 weevils per trap, by the time the leaf stage, we recommend an insecticide spray. There is also a second insecticide spray if you continue to find weevils and your counts continue to increase by the fourth leaf stage. There is also another way, if you don't have the boy vent traps, if you don't have a way of making them, there's also a way to just use carrots, like you saw a couple slides ago, just kind of buried in the ground with the top sticking up. There's a way to use bait carrots to also have a threshold. So that threshold is spray if a quarter of the carrots show oviposition damage. So I showed you that carrot a couple of slides back as well, those little pits on it or any sort of eggs like you see there in the picture. That counts as oviposition. If a quarter of the carrots you put out have those sort of signs of feeding, then that would also trigger a spray threshold. Okay, that's all I have for carrot weevil. If you have any questions on that, just write a question in the chat or throw it up on Slido anonymously as well if you'd like, and I can get back to them probably at the break. So let's get into carrot rust fly. Carrot rust fly has similar to host range that carrot weevil does, in that it mainly feeds on the Apiaceae umbelliferous family. So that's your carrot, celery, and parsley. It overwinters in Ontario as a pupae. So that's a life stage in between basically this adult fly and the larval stage. It has 2 generations typically. Sometimes we see 3 if it's a warmer year, but the first generation usually comes out in early June, and it's usually right around the lilac bloom. So it's kind of helpful sometimes to trigger or to associate the peak insect emergence with flowering of other plants. So the first generation of carrot rust fly is usually associated with the lilac bloom. Second generation is usually mid-August, and if we do have enough heat units and degree days in some areas, and the third generation is sort of late September and early October. So that's the little fly you see there. It's quite small. You may recognize this from the quiz. It has 3 distinct body parts. So thorax, abdomen is usually black and shiny, and then it's sort of an orangish head with yellow legs. So that's what you're looking for in terms of carrot rust fly. The damage it does is also tunneling and feeding of the larval stages. That's the most damaging stage. But it's a little different than what you'll see with carrot weevil. So carrot weevil is usually at the top third of the carrot because they usually lay their eggs on the crown and then they tunnel down. With carrot rust fly, the adults lay their eggs in the soil near the carrots, and the larvae usually tunnels down deeper into the soil and will usually infect the lower 2/3 of the carrot root. So that's going to be different than carrot weevil. It's usually lower down. It also is usually smaller cavities. And if I would describe a carrot weevil cavity as sort of an open ravine or canyon type of cavity, the carrot rust fly is more of a tunnel mining cave sort of damage. So they'll wind their way around the carrot root, tunneling and feeding. You'll see sort of pinprick marks where the larvae kind of pokes its head out and then goes back in as well. That's pretty diagnostic with carrot rust fly. It's more like the type of damage that a wireworm is going to do to a carrot, but the wireworm damage is going to be much larger, almost as big as a carrot weevil tunneling, if not larger. Carrot rust fly is kind of slight damage. It's usually just underneath the skin, and it almost like discolors the skin of the carrot. What are we looking for? I mentioned before those black shiny parts, and then the orange head, yellow legs. With one interesting tip when it comes to insect ID is that for most beetles, their larvae will have that orange head. So with carrot weevil, remember you saw that that larvae, and it had that orange or orange to brown head on it. When it comes to flies, so carrot rust fly or house flies or other sort of flies that create maggots, those maggots do not have that distinct head part on the larvae. So that's going to be also an easy way to tell if you pull up a carrot and it has feeding damage and you find a larvae. You can tell whether that's carrot rust fly or if it's carrot weevil based on whether or not the larval maggot has a head or not. If it does have a head, it's a beetle and it's carrot weevil. If it does not, it's more likely carrot rust fly, and in some cases seed corn maggot. So yeah, I mentioned the larval stages. This is the pupae at the bottom right. They pupate in the soil. And this is what they look like on a sticky card. So we use yellow to orange sticky cards to monitor for these at the edges of the field, which I'll get into in a little bit. And 90% of the time, this is what carrot rust fly looks like on a sticky card. It's quite distinct. It has those shiny black distinct body parts. It has an orangish head. Kind of looks a little different once it's on a sticky card after a couple days, but it has a sort of orange head, you can tell, and it has those yellow dangly legs typically hanging out underneath it. So that's 90% of the time what you're going to find carrot rust fly looks like on a sticky card. There's also degree day monitoring developed for carrot rust fly, which predicts when the emergence of the different generations are going to emerge. So this is helpful for knowing what to keep an eye out for when you're scouting a field. This is also reported on our vegetable crop report weekly. So if you subscribe, you'll have updates as well for your area of whether or not you're expected to see carrot rust fly out and about. I mentioned we use yellow orange sticky cards to monitor for them. And we typically use 5 traps per field. We put them in an L shape around the edges of the field. So on 2 sides of the field, we'll run them down the perimeters. And they're placed just above the carrot canopy. So as the carrot canopy grows, we move the traps up the stake that we use to stake them on to keep it just above the carrot canopy. The reason for this is that carrot rust fly actually lives outside of a carrot field in the surrounding vegetation. So it likes bushes and other vegetation to live in, but it'll fly into the carrot field in order to lay its eggs. It's also not a very good flyer, so it doesn't fly very high. It kind of just flies slow to the ground and hops over any obstacles. So that's why we keep it just above the carrot canopy. So as a carrot rust flyer is sort of lazily flying over the different rows in the carrot canopy, the idea is you get them stuck on those sticky cards that they're attracted to. So this is what the 2 main insect monitoring traps look like in a carrot field. We have our sticky card there. It's attached via a bull clip to a 1x2 stake. And then behind it, you see a boy ven trap. So there's a carrot in there, provides a nice little habitat. Any carrot weevils walking around hopefully will go to this trap instead of attacking the carrots. This trap is probably a little too low. It should be a little higher up on the stake to keep in line with the top of the carrot canopy. You've seen this graph before at the bottom. This is the carrot rust fly thresholds. There is a spray threshold for carrot rust fly of 0.1 flies per trap per day for fresh market carrots and 0.2 flies per trap per day for processing carrots. So processing carrots have a little bit more tolerance for some rust fly damage. Fresh market carrots have a much lower tolerance. Our recommendation is to check twice a week so that you don't miss any of the peaks, but once a week is okay as well. And this is different than the carrot weevil count, which is cumulative. You're basically taking how many flies you found on that trap, divided by 5, the number of traps you have in the field, divided by how many days you were last scouting that field. So typically 3 if you're doing it twice a week, or 7 if you're doing it once a week. That'll give you a number, and whether it's lower or above that 0.1, 0.2 spray threshold, you can report that back to the grower. That's it for carrot rust fly. I'm going to get into aster leafhopper now. You may also recognize this insect from the quiz earlier. The main problem with these aster leafhoppers is that it is a vector. It is a vector for a phytoplasma. that can infect a wide range of crops. It has a very wide host range and can create some sporadic, really extensive damage in some crops. The adults are sort of a greenish to almost iridescent color on their hind parts. So it's sort of a green, yellow, green, gray with a darker thorax, around 3 millimeters in length. And what's distinct about the aster leafhopper is it has 6 distinct spots on its head. This can be tough to tell sometimes when it's on a sticky card, but if you had a hand magnifying lens, you can often see it. Or if you bring them back and you have a dissecting scope or something like that, you'll see these black spots on the top of their head. Their wings extend past their body as well. And the nymph stage you see there at the bottom right will also typically be found in the crop, but it can be harder to ID. They're quite quick and they're quite hard to see, and you might be mistaken for something like aphids or something like that as well. We have a local population of aster leafhoppers. They're typically on overwintering winter grains. They're hanging out in those fields. And when those crops are harvested, you'll typically see a flush that move into other fields. We also have a population that move up from the south on weather patterns. So we can kind of predict based on degree day monitoring when the local population is going to emerge, and based on what crops are being harvested in the area, when we're going to see a flush. It's this population coming up from the south that can often be very damaging because we don't know when it's coming. They can come in a big flush at random times. And these populations often sometimes have a higher percentage of the phytoplasma in their populations, which means you'll see more and more of the aster yellows, which is a result of the phytoplasma showing up. So it's harder to predict when this is coming up, and we also don't know how high their infectivity is. Usually we see a flush in June. That's the local population. And they have a wide host range, as I mentioned. This is basically a charting of aster leafhopper counts. In this year, it looks like we had a nice distinct peak based on that mid-June to late June emergence, probably of that local population. We didn't seem to get any flushes for most of the summer, and that late August is either a local population or a flush coming up from the south. We use a degree day base 9 for aster leafhopper degree day models. Egg hatch occurs usually at 128, adults emerge at 390. So we also include this degree day model in our vegetable crop report. So again, if you follow that, you'll get updates on whether or not we expect a local population to emerge in your area. We use the same yellow-orange sticky traps we use for carrot rust fly to just monitor for aster leafhoppers. Typically, they're a good representation of what's around. They usually correlate with what you're seeing in the field with sweep nets to what is shown on the traps. You can also use sweep nets. So if you have a sweep net, especially if you start seeing higher numbers on traps, it's good to use a sweep net and see what's actually going on in the field. That's a good representation of what your current population is. This is what a larger amount of aster leafhoppers look on a sticky trap. So they are quite difficult early on if you don't know what you're looking for to identify. But the majority of these are actually aster leafhoppers. I want to point you to a couple of leafhoppers on this trap that are not aster leafhoppers and that it's very easy to mistake aster leafhoppers for. That's one on the sort of bottom left-hand side. It's kind of a smaller leafhopper and is more of a lime green yellow. And the sort of top right, just underneath that larger Delia maggot fly, it's a yellow green leafhopper. Those are potato leafhoppers. They are brighter. They are a little smaller than aster leafhoppers. They're more of a sort of lime neon color. Aster leafhoppers don't typically have that same sort of shine. Their back parts are darker than potato leafhoppers. Potato leafhoppers don't usually cause a lot of damage in carrots. It's the aster leafhoppers that vector that phytoplasma that are the real issue. So early on, if you'd like to send me pictures or to send cards that you're not sure of to correctly identify, I'd be happy to help with that to kind of tell the difference between the two until you get a feel for what aster leafhoppers look like on a sticky card. So what's the problem with aster leafhoppers? Well, they cause aster yellows via vectoring that phytoplasma. So this is what aster yellows looks like in carrots. You see that really distinct red leaf. That's really the first sign that you'll see walking through a field, is that really bright red leaf. And then if you go down to that in the canopy, look at that carrot, you'll see there in the bottom left, there'll be a proliferation of roots and of new growth. So there'll be tens to hundreds of new shoot growths at the crown of the carrot. And if you pull that carrot up, all those root bases will be just spitting out a whole bunch of new roots, and it'll look all hairy and sort of mangled and gnarly. That's typical of aster yellows. So a really diagnostic red leaf. You'll go down, you look in the soil, you'll see funny root growth, and you'll see funny shoot growth as well. So that's what it looks like in carrot. You may also recognize this as from a quiz question. One thing that's important to monitor for is to get ahead of the aster leafhopper populations, because they do require several hours of feeding to transmit. And there's also a 4-day incubation period. So by the time you see symptoms in the field, it was already caused by a population that was in the field from almost a week ago. So it's important to get ahead so that the growers can take management steps if they need to. It's not thought that the disease is passed from adults to offspring, which is good news. So aster leafhoppers have to feed on other infected plants in order to transfer that phytoplasma to other infected plants. This disease, you may not see it at all this year, or we may have a huge explosion of it like we saw in 2014. We really don't know. The severity of aster yellows in every given year depends on basically the size of leafhoppers that are getting blown up from the south and what the percentage of infectivity is in that population. We really don't know that until we start to see symptoms in the field. So make sure that you're monitoring beforehand to see if we have any flushes that are entering the field before we start seeing high levels of damage in the field. Some more pictures of what it looks like in the crop. You may see some start to sort of yellowing, which turns red there on the right-hand side. Very distinct. If you're walking through a carrot field, you'll notice it and you'll be attracted and go and see what's going on in that area. Wireworms, if you've attended some of our workshops, you've probably heard lots about wireworms, and you'll probably hear more about them. They are the larvae of click beetles, so they're actually a beetle species. Very distinct in the soil. They can last a couple years within a soil. They love grass species, so if any field was pasture or something like that, you usually have high levels. And they can cause huge damage to root vegetables. So potatoes, they can cause huge damage. Same with carrots if you have high population. So they really, and they infect that marketable portion of the crop. It can be really damaging. And they're quite hard to control. I see, before I go any further, there's a question in the chat. Are there sticky trap thresholds for aster leafhoppers? No, there is not any developed threshold. There hasn't been any research to tie the levels of aster leafhoppers on a sticky trap to the amount of damage they cause, just because the infectivity is sort of all over the place and it varies from year to year. But a general rule of thumb that we typically use is you take your highest single count from your 5 sticky cards. So it's not necessarily a threshold, it's just a sort of a general rule. Anything from 0 to 10 we kind of consider low to medium. Anything over 10, from 10 to 20, is usually a higher amount than what we typically see. And any counts, single trap counts of over 20 would be considered a high amount of aster leafhoppers in the area. So no developed spray thresholds necessarily, but just sort of a relative abundance that we use would be 0 to 10, 10 to 20, and then 20 plus would be a high amount. Thanks for the question. That was a good question. I'll talk about millipedes a little bit as well. Very sporadic, very localized pests, but you may see some sort of weird damage that you could tie back to millipedes. In general, they're actually beneficial because they'll kill some insects that can attack carrots. But there's sort of 3 species. This is sort of what millipede damage looks like. Sort of kind of like carrot weevil damage, but sort of open, dry feeding, not necessarily tunneling, but more open feeding cavities. You can monitor for wireworms specifically, but also for millipedes. If you are a scout for any cash crops that want to use neonicotinoid seed treatments, maybe you're familiar with trapping for wireworms. You can use a pitfall trap, so pretty easy to set up. Basically just put a little bit of low tox antifreeze in a cup buried in the ground so that the insects can walk over it, and just kind of stake out a little cover so that rain doesn't fall into the trap. So basically the wireworms or the click beetle adults will walk around and fall in your pitfall trap, and you can count them as you scout the field. You can also bury some corn or carrots in some cases, some sort of bait crop in the soil, and come back later to see if there's any of those larvae that are attracted and feeding on that. So one of the last slides is sort of, so what does it look like when a carrot field is set up with all the traps I've been talking about? So those Boyven weevil traps I've put as a blue rectangle, and the orange sticky traps there is the yellow-orange squares. So in this scenario, this carrot field, I would typically put the weevil traps sort of by the road in one, and then up the field in the other. So in this area, a carrot and onion rotation is very typical. So if you see on the left-hand side there, that's actually an onion field that has started to lodge. So if that was onions, I would assume that was probably carrots the year before. So there might be a high population of carrot weevils in that field that are walking into the current field this year. So I would put a weevil trap on the side of where the carrot field was last year, and of the side of the road or ditch where I think they might be overwintering as well. If you look across the road, you see sort of a lawn as well. So if there's no ditch beside the road that they could hide in at some sort of overwintering vegetation, they may also just walk across the road and burrow into that lawn. So I would put it near some of those riskier places. In terms of carrot rust fly traps, same sort of thing. I'd sort of put it by the road. It's easy to check. And across the road is where we have sort of structures, right? The bushes, your houses, your barns, where those carrot rust flies are probably living and then making their way into the carrot fields. So I'd want to catch them as they make their way into the fields by putting them there, and then up one of the sides as well. Not as important if it's in the middle of nowhere like this field is. It doesn't really matter which side you put it on. But if there was a barn or some sort of structure on one side, I would put it next to that barn. And that's all I have for carrots. I'll hand it back over to Travis.
Right. Ah. Oh boy. Is that better?
Should be good now.
Beautiful. Thank you. All right. I'm going to touch on the pests that, well, Dennis talked about many of the same pests, or some of the same pests that attack celery also attack carrots. So I'm going to focus mainly on the few that are different, primarily aphids and tarnished plant bug. So with aphids, there's a bunch of different aphids that we have in Ontario. They all have this piercing, sucking mouth part. They all impact yield. Most of them are pear-shaped, and they all have cornicles, which I'll talk about in a bit. Lots of different colors. Left unmanaged, they could get out of hand real quick. So just some background, they reproduce really quickly with up to 15 generations per season. And when they reach high numbers, they stunt growth, produce honeydew, which results in the sooty molds. They help vector diseases, and they contaminate the crop. So there are 3 stages: egg, nymph, and adult. and adults can be winged or wingless. The most distinguishing feature is the cornicles at the hind end. So I have a diagram coming up here to illustrate what the corticals are. If we were to zero in on specific aphid species, the green peach aphid has a very wide host range and moves into celery or a lettuce field in the summer. Generally starts on the lower leaf surfaces and move up the plant. They're dark green to yellow. They don't have a waxy coloring, around 2 to 3 millimeters in length. Convergent tubercles, dark dorsal patch, and yeah, they really range in their colors. Potato aphid, multiple hosts. It is often mixed up with the green peach aphid. They tend to target the youngest leaves and is slightly larger. There's a lettuce aphid, but it's not as common. In lettuce, it feeds under the cap leaf and feeds towards the younger leaves as they develop from the apical meristem. It comes in a range of colors, and these distinctive black markings that are located on the antennae and on the legs. As far as threshold go, if it is greater than 5% of the plants, if 5% of the plants have aphids, this is considered high. If there's 1%, it is high if you're less than 2 weeks from harvest. And if there are less than 10 aphids per plant, that is a light infestation versus more than 20 aphids per plant, that is considered severe. The next insect is tardish plant bug or lygus bug. The adults have this yellow triangle just below, at each wingtip. The nymphs are green, and sometimes you're able to see those spots there. Tarnished plant bugs will often be found on field borders, moving in from weeds. It has 2 to 3 generations per year and causes these necrotic lesions on the celery stalk. So here's a tarnished plant bug nymph. You can see it hopping around, bouncing. It moves a lot quicker than an aphid would. This is the type of damage that you might find if tardish plant bug is present in the celery field. So you've got these necrotic lesions along the stem. Can be confused with lesions that celery leaf curl leaves, which we'll discuss later in the pathology section. So when you're scouting for tardish plant bug, you want to record the number of tarnished plant bugs and divide that by the number of plants you examine. The thresholds are 0.2 tarnished plant bugs per plant in season, or 0.1 tarnished plant bugs per plant less than 3 weeks before harvest. I mentioned earlier that tarnished plant bug nymphs and aphids look very similar. The tarnished plant bug on the left will move quick, it will bounce around, and while the aphid will move slower, and it has corticles on the rear end. So these are the corticles on the aphid, and here's our tarnished plant bug with those black spots on the black back. So as a quick summary, tarnished plant bug, it moves fast, doesn't have those cornicles. Aphids are slow moving, they have those corticles, and leaf hoppers, they lack corticals and are fast moving. Dennis talked a lot about leaf hoppers. I'm not going to say much about them other than on celery, they cause yellowing, twisting of petioles, and overall they stunt the crop from that, like the astruyellus phytoplasma. There's also pea leaf miners that lay their eggs on leaves. The eggs hatch out and mine the leaf, and once they are large enough, they fall to the ground to pupate. The symptoms can range from, a single streak in that stalk to substippling on the leaf to the whole inner leaf being compromised. The celery leaf tear is an uncommon nocturnal moth that has a green larva, and it is distinguished by being pale yellow with a dark green stripe along its back. It eats the leaves and stalks and ties the leaves together, kind of folds it into a web. I've yet to see this in person, but it's out there. And there's carrot weevil on celery. Might have seen this in the quiz. It's uncommon, but if celery and carrots are in a tighter rotation, then you might see it more frequently. Basically, it attacks the hypocotyl or base of the stalk and stunts the plant there. The last insect I'd like to discuss are climbing cutworms. These guys feed at night, and while uncommon, you're more likely to see the variegated ones. So here's a climbing cutworm, just fill it up in the celery leaf canopy. Right on. So if you guys can log back on to Slido, use the event code IPM, and we'll go through the questions that we went through at the start of the entomology presentation. Yeah, I noticed I was cutting out for some of the presentation there. If you have any questions, feel free to put them in the chat. It looked like my internet connection was a little unstable. Okay, so what is this insect? Aster leafhopper, carrot rustfly, carrot weevil, flea beetle, seed cord maggot, or tarnish plant bug? Give you a few more seconds to log in there. 5, 4, 3, 2, 1. All right, we'll lock the polling. The correct answer is carrot weevil, and 50% of you got it right.
Very good. I'll just point out one thing as well. It might be a little difficult to see, but if you look at the larval there, you see it has that orange to brown head on there. That's going to be the diagnostic spot point of that larvae. Is that head with that damage most likely going to be carrot weevil.
Right on. All right, next question. What is this insect? Aster leafhopper, carrot rustfly, carrot weevil? Is it an aphid? Tarnish plant bug? Five, 4, 3, 2, 1. Get your answers in.
Wow, you guys did it.
Right on. Well done. All right.
100%.
Next one. What caused this? Aster yellows, carrot weevil, nutrient deficiency, violet root rot, or white mold? Five, 4, 3, 2, 1. Right on. 78% of you got that right with Aster yellows, most likely vectored from Aster leafhopper. What is this insect? Master leafhopper, carrot rustfly, carrot weevil, leaf miner, wireworm. 5, 4, 3, 2, 1. Carrot rustfly is correct. Well done. What caused this? Aster leafhopper, carrot rustfly, carrot weevil, flea beetles, or wireworm? Open tunnels. 5, 4, 3, 2, 1. Right on. Carrot weevil is correct. All right, what is this? We've got a celery plant, some damage along the stalk, maybe something in the stalk there. It's a tarnished plant bug, black heart, carrot weevil, celery leaf curl, bacterial rot, or cutworms.
This could be the toughest one.
Yeah. Five, 4, 3, 2, 1. All right, so 50% of you got it correct. It is carrot weevil damage. If you look at the stalk here, we have a carrot weevil larva just chilling there, and you can see that headpiece similar to the first question of the quiz. So this celery was probably planted next to or in a field that was carrots the previous year.
Could be some bacterial rot setting in as well from the feeding, but primarily it's going to be that carrot weevil feeding that caused those entries.
And our last entomology question, what is this? That chattering along the leaf, brown lesions, is it tarnished plant bug, black heart, carrot weevil, aphid, celery leaf curl, or cutworms? 5, 4, 3, 2, 1. You guys got it right. It is tarnished plant bug. I don't know why cutworms is highlighted. There we go. Right on. All right. So if you have any questions, feel free to put them in the Slido chat or in the Zoom chat over the break. We're gonna have another 10-minute break, and yeah, we'll meet back in 10 minutes.
Okay, so let's get into diseases. We'll do a little bit about carrot diseases. Travis will cover celery diseases, and then we'll also talk a little bit about like general disorders and things like that at the end. So the main diseases you're going to see in a carrot field in Ontario are leaf blights. So there's two main ones that we're typically going to see: Alternaria and Cercospora leaf blights. You'll likely see white mold as a huge host range. You probably saw that on the quiz. And then some soil-borne diseases. It's because carrots, of course, are grown in the ground. The marketable portion is in the ground. They're really susceptible to all kinds of soil-borne diseases. So Pythium is a huge one. It causes a couple of different symptoms, a couple of different problems. Violet root rot and nematodes. Those are all very common diseases you'll likely see this year. So I'll first talk about leaf blights because that's some of the more obvious ones. The two main ones are caused by two different fungi in Ontario. Which one you see kind of depends on which region you're in and on what type of weather we're experiencing. In terms of thresholds, they're often managed the same way, rightly or wrongly. So we have a spray threshold of 25% incidence within the field, and that's for any infection of either of these two leaf blights. So first I'll cover Cercospora. You may recognize these oval spotty lesions. So for Cercospora, to tell the difference, I usually think of circle or spot as sort of from the name. These ones have elliptical lesions on the stem. That is very diagnostic for Cercospora. Not the other leaf blights don't typically have those elliptical lesions on the stem, and as well as those spotty lesions on the leaves. So they have those brown spots surrounded by sort of a yellow halo. That's very characteristic of Cercospora. If we look at Alternaria is more of a burning leaf blight. So usually you'll see Alternaria start at the tips of the leaf. It'll sort of infect the tips and move down, and it almost looks like the leaves are starting to be burnt off. You see that at the bottom left there, sort of that hot spot of leaves starting to die. So this one usually starts at the leaf margins, as you can see, and then works its way in. So that's Alternaria, more of a burning leaf blight. We also might see a less common one, but it's called bacterial blight. So these ones cause sort of irregular dark brown lesions. What's typical about the bacterial blight is it causes some weird warping of the leaves. So bacteria acts differently than fungi, right? I'm not sure if anyone was at the intro.ipm, which covered a lot of this, but basically bacteria gets in often through the hydothodes. So it'll get into the leaf, but it might be restricted to a certain part of the leaf by the stem or something like that. So it'll kill off a part of the leaf, but the other part will still be healthy, which means it might curl around the dead part and might have some weird warping, which I can show you here. So this is typical of bacterial spots. So you see those bacterial spots there. You can see on the tips as well. It looks like the bacteria is getting in from the edges, and it's infecting only at like half of that leaf there. And that's causing the healthy leaf to continue to grow, and it's starting to warp around the dead part. That's sort of very typical of what you'll see with a bacterial infection as opposed to Alternaria. Why is it important? Well, the lost leaf area reduces yield, and I showed you those pictures and videos of how carrots are harvested. Oftentimes they got to pull them out of the ground. So if you have a lot of compromised top growth, when the belts pick up the carrots will just fall off and fall back into the ground. So you grew that crop for nothing. So I mentioned already the spray threshold is 25% of leaves that have symptoms. So when you're out scouting, you're going to stop in a couple different spots. You're going to sample 5 to 10 different plants in that spot where you're going to crouch down and really look at it. So if 1/4 of the leaves that you find have some sort of leaf blight on them, that would trigger a spray threshold. Once we start seeing later on in the year, we'll have a lot of leaf blight in the lower part of the canopy. I showed you that closed canopy before. Leaves stay wet, which is perfect conditions for leaf blight to spread. So later on in the season, you might have 100% of the carrots in the field have some sort of leaf blight on them in amongst the canopy, but the top and the newer leaves are all really healthy. So what we usually say is that later on in the season, you don't count the lower leaves, you just count the sort of top, the recent 3 to 4 recent leaves, and see if they're healthy, because that's really the most important part. I mentioned in between the canopy is really conducive for diseases. This is one that loves to be in between the canopy. This is white mold caused by Sclerotinia. Cottony white growth, very distinct. So Sclerotinia will get in on those old or dying leaves at the bottom of the canopy. It'll start to infect, it'll travel down that petiole, and it'll get into the crown of the carrot, so that when you harvest the carrot, it'll be in the crown, and this is really a problem in storage. The storage disease that can tear through a pile or can tear through a box and basically turn the carrots to mush. So one distinctive thing about Sclerotinia is those sort of black hardened sclerosis structures. Almost looks like mice turd in and amongst the white mold. It's very distinct, and that's very typical of Sclerotinia. So this one is quite nasty if you get it in storage, as the basically liquefies the carrots. A more rare disease you may see is powdery mildew, which is more typical in the southwestern part of the province, but a sort of powdery residue, almost looks like spray residue on the leaves. And that's very typical of the powdery mildews. Not typically a huge issue, but it does reduce leaf symptoms, so you do need to report it back to the grower. Violet root rot, it's a rhizoctonia. It can be very devastating. It's a very localized disease, like maybe restricted to certain fields that the grower knows. But same sort of thing. You look in that canopy, you'll see the white cottony growth, but it'll be different than the Sclerotinia white mold in that it'll definitely have a sort of purplish tinge to it. So it won't just be white, it'll have a purplish tinge. It'll be infecting near the crown. And if you pull up these carrots and the carrots in the area, it'll look like that bottom right picture. All the soil will be sticking to it. And if you wipe off that soil, it'll start to turn purplish. You can kind of see that at the top right. The whole skin will sort of be discolored and starting to rot a little bit, and it'll have a purplish hue to it, hence the name violet root rot. If we move on to nematodes, there is a couple different nematodes that can cause problems in Ontario. The ones that affect carrots are usually either root knot or cyst nematodes, and these cause forking and galling. They cause sort of a hairy root appearance, right? A lot of secondary roots. You see that in the bottom left picture and the right picture, and that's that forking. And you can normally, you have to really look and see either cysts or galls on those roots as well. So nematodes are actually animals, so they're little roundworms. So when they get into a plant root, this is actually a root lesion nematode inside the plant, a root of a plant. So they'll use their stylet, their basically little needle appendage in their mouth, to basically break down the cell walls. In the case of cyst and root knot nematodes, they will use the stylet to inject proteins and other things that will actually turn all of these plant cells into massive cells. So those plant cells will just continue to grow and grow and grow. They will differentiate, or they will replicate, but they will not undergo mitosis. And so those root knots and the cyst nematodes will just set up shop and just have a permanent feeding site where the plant is just feeding them nutrients from those massive giant cells. So it can be quite devastating because they take a lot of nutrients from the crop, but they also leave it forked and all those galling. So you see on the left there, that's root knot nematode. And you can see on the right, those tiny little cysts and all those finer roots. That's why it's important to have a trowel or a shovel with you. If you see a spot where it's starting to yellow off, or you start to see a lot of forking in some hot spots, dig it up with a trowel so that you can preserve these secondary roots and tell whether it's nematodes or not. A soil sample will also help with that. I'll talk a little bit about Pythium dieback. This also causes some forking and stunting, but you typically see it earlier in the season, so it'll be a very stunted or stubby carrot. You may also see some of those secondary growths and numerous taproots. The issue with forking carrots in general is it can be caused by a huge number of problems. Could be nematodes, could be Pythium. Those are the main two, but it can also be caused by compaction, saturation. This year could be caused by frost events, which we've had, which you might have to look out for. So any significant stress on the carrot early in its development is going to mess with that taproot development and will cause a bunch of forking and stunting. Another Pythium disease that is a problem is called cavity spot. So this is Pythium that will infect not the main taproot and cause forking, but it's Pythium that infects the secondary roots and will kill off those secondary roots and leave these scarring on the side of the carrots. So you see on the left sort of smaller elliptical scars, that is cavity spot, but so are the bigger ones as well. So as those scars as the carrot grows and develops and stretches, those scars grow and develop and become more prominent and larger. The issue really is in storage, where they're not always dark like this. They will turn darker and darker and become larger in storage as well. So the longer you store the carrot, the worse these look. Crater rot is caused by rhizoctonia. Doesn't have nice elliptical lesions. It's kind of a random, and these have more sunken, almost rotty looking lesions on the side of the carrot. There she goes. Fusarium is a sort of a relatively new disease within the last, I would say, decade. Right now, it's localized to a certain fields, but it's quite a devastating disease. It has these large black nasty lesions that show up on the side of the carrot root. And what's typical about them is that they're larger than cavity spot, and they have these large cracks running laterally along the carrot that seem to develop as the lesion spreads. Crown gall is a disease agrobacterium that has a very large host range. Not a huge issue in carrots, usually often associated with high nitrogen. A lot of times these galls will just break off the side and the carrot will still be marketable. But so this is what crown gall looks like. It can be sometimes difficult to tell it from nematode damage, but it's very distinct, has brown and almost looks like multiple growths and cankers almost. There is in your handouts a scouting calendar in there. It might be helpful to see when you expect to see insects and when the diseases are expected to show up for your reference. And with that, I'll hand it back over to Travis.
Right on. Thank you. Can you hear me okay? We'll start with a bit of we'll start with plant pathogens of celery. So perfect. So many pathogen IDs require cutting celery, and just a word of caution, should always wear gloves, and if it's not too hot, long sleeves, and avoid coming into contact with celery juice if you're digging up a plant that's wilted and it's oozing celery juice, or if you're cutting that stalk in half. Contact with celery tissue followed by exposure to sun may lead to blisters and other skin reactions, just because it's phototoxic. And while blistering does not happen to everyone, skin reactions are not fun. So wear gloves or wash hands after cutting parts of the plant. First pathogen that I'd like to start with is Cercospora leaf blight, which creates these tan yellow spots on both sides of the leaves, turning the tissue papery. It's often referred to as early blight, but it can be found both early and late in the season. So on the stem, you might get some brown lesions that can be mistaken for tarnished plant bug damage or celery leaf curl. As a scout, you would want to record where you find the Cercospora leaf blight in the field. Late blight or Septoria leaf blight has smaller brown spots, and they have black pycnidia. If you were to zoom in and look very closely at these gray to brown lesions, you might be able to see black tiny dots, and these pycnidia spores form inside the lesions. This pathogen is generally found later in the season, but it can be found early in the season as well. So fungi starts on the leaves, and then it moves to the stem or petioles over time. As a scout, you want to avoid scouting late blight or Septoria leaf blight if the plant canopy is wet. If you found Septoria in that field the previous week and you go to that field this week and that canopy is wet, maybe leave that field for later. If possible, these spores can spread quite easily just on your clothes and you moving through the field. So as a scout, you want to identify where it is in the field and look for those pycnidia or tiny black spots in the gray lesions to confirm it. Next pathogen is Fusarium yellows. It's caused by a fungi colonizing that vascular tissue and robbing the leaves of nutrients, which cause the leaves to turn yellow, stop growing, they're stunted before they turn brown and die. So if you were to pull out this plant, take a cross section of that stalk or that base, you should see these brown stains, which is pretty characteristic of fusarium in the vascular tissue. Here's a bunch of management strategies. As a scout, you'd want to clean your shoes between the fields, avoid driving vehicles into fields, and cut open any stunted plants and record that that you found fusarium yellows in the field if you come across something like this after cutting a cross section. Pink rot is caused by sclerotinia, which is a fungi with white mycelium that can cause the affected tissue in celery to turn pink over time. So it won't be bright pink, but it will have a pink hue. As it develops, just like in carrots or in brassicas last week, we see these black sclerotia form that look like mouse droppings if conditions are favorable. It's a weak pathogen, so it often colonizes where there might have been damage from machinery or someone walking through the field a previous week, insects, or even the wind. That's where it's going to colonize. Really important to allow the celery crop canopy to dry from like the morning dew or between irrigation events. Just in general, not only is it uncomfortable to scout a celery field if the canopy is super wet and it's closed in, but it's a great way to spread pathogens through the field. So limit spore spread and avoid scouting when the leaf canopy is wet. Next, we have leaf curl caused by Colototricum acutatum. This fungi has several symptoms, but the most distinct is the downward cupping of those leaves. The second symptom it has are cracking or streaking along that stem, and it also has adventitious roots that can develop below the stalk, and crown rot that's very similar to blackheart, which Dennis will cover in the disorders section. So if you find leaf curl in the field, rogue out those plants if possible. Putting them into garbage bags may help with the spread, but you have to be mindful about it because if you touch those infected plants and then touch healthy plants after, there's a good chance that you could spread spores, especially if the leaf canopy is wet. So avoid touching any plants after you touch affected plants. As a scout, you'd want to record where you're finding it in the field every week. The next pathogen is cucumber mosaic virus. It causes this mottling of the leaves. It's vectored via aphids, and if it's good weather for aphids, this pathogen can spread quite quickly. Can be mistaken sometimes for abiotic disorders or genetic mutations. So you can ID it with an egg dia immunostrip or send a sample to the lab to confirm that it is actually cucumber mosaic virus. So as a scout, you want to look for aphids, record those aphid populations, and if you find any symptoms in the field, where you're finding those symptoms. Once again, talking briefly about aster yellows vectored by the aster leafhopper. Dennis covered this insect pathogen complex in detail, but I wanted to show you a few pictures of the damage that it causes in celery. So here's a bit more about its life cycle. And the best method of control in celery is to manage those aster leafhopper populations. So Dennis mentioned you can monitor for this insect using yellow or orange sticky cards. Want to line them up on the south or west border of the field. And as a scout, you would want to record the number from the trap that has the highest count. If you're using a sweep net, do 20 sweeps in 5 locations and record the number of leafhoppers based on those 100 sweeps. We'll move into nematodes. Root lesion nematode also attacks celery. Symptoms look like nutrient deficiencies or wilts above ground, and if you're looking at the whole crop, it can be seen in patches or sometimes in rows. This nematode penetrates and feeds inside the root, Females lay eggs inside that root, and the life cycle can be completed in as little as 40 days. If you determine this is the nematode of concern, you can plant early if possible. Avoid rotations with highly susceptible crops like soybean, wheat, canola, oats, rye, chickpea, or mustard. Remember to have that trowel handy, and plants that look stunted in the field, dig up those plants, carefully knock off the soil from the roots, and inspect those roots for those lesions. Our second nematode is root knot nematode, which also causes stunting, wilting, and yellowing of the leaves. Use that trowel again, dig up those roots carefully, and you want to look for those small root galls, or they kind of look like nitrogen fixing nodules that you would see on legumes. One female can lay up to 1,000 eggs, and with the life cycle being completed in as little as 25 days, these numbers can grow quite quickly. So as a quick summary, identify the nematode, and if it's root knot, avoid susceptible crops like onion or brassicas or barley. Observe a minimum rotation of 3 years and control those susceptible weeds. If you have any questions about celery pathogens, feel free to enter them in the chat, and can address them after we're done the disorders section of the presentation. So hand it over to Dennis, who will take us through the physiological disorders of carrots and celery today.
Great. Thanks, Travis. Okay, so I'm going to go over some common physiological things that you may see in these fields. We put it at the end because I think it's important to rule out diseases and insects before you, I guess, settle on a physiological disorder. A lot of time physiological disorders are difficult to control. There's not much a grower can do, or nothing the grower can do. So it's important to rule out issues like disease and insects that a grower may be able to take management strategies against. So physiological problems could be weather related. So this year, especially something like frost. Maybe later we'll see some heat canker, drought, waterlogging, hail, lightning, those sort of severe weather events. It can also include nutrient deficiencies, soil issues, and then spray drift as well. Diagnosing physiological disorders is difficult sometimes. It's important to look at the pattern within the field. Are there hot spots? Is it a couple strips? Is it a couple beds that are infected? Is it the whole field? Is it just a certain part of the field? Those are all really important things to keep in mind. Is it natural? You should know the growth stages of your crop. Is it natural that when you transplant celery, for example, that a lot of the leaves will die off just due to transplant stress, but the plant will be healthy? It's important to know these things and to know the life cycle of the crops. Is it a result of another problem? Soil compaction, lack of water, too much water, and like I mentioned before, rule out disease and insects first. So it's important just in general to survey the whole field first before you walk in it. Look for any hot spots that you can see from the road that you may want to focus your attention for sure. It's important to be in constant communication with the grower as well, not only for pesticide spraying and reentries and things like that, but also for, did the grower spray any fertilizer? Is there anything else that could be causing these issues that the grower did that could explain what you're seeing in the field? It's important for scouts to be aware of the weather and to keep updated. It's important to know if the field was hit by severe weather events, if there was pounding rain in the area, if there was hail. A scout should be aware of any potential issues that might be causing problems in the field. Frost damage is very topical right now. If you're going to be out in the field anytime soon, you'll likely see results of these heavy frosts we've had and this stretch of cold weather. A lot of growers have tried to irrigate through this. Just in terms of a wet soil will has a potential to hold more heat through the nighttime. But a lot of recently transplanted crops may be in bad shape. So it's important to know sort of what frost damage looks like. It really varies by the different crops. So this picture was taken on the same day with a hard frost. This is a later in the season frost, but it just demonstrates how the different crops react to different frosts. Some are quite frost tolerant. Look at the peas, it looks fine. But whereas pumpkins got completely wiped out by just a single frost event, artichokes are okay. So some transplanted crops, some other recently seeded stuff may come through okay. Other crops may be really damaged. Transplant stress in young celery transplants. This is quite common where in a recently transplanted celery, the old tall leaves from the greenhouse will actually die off. But that growing point you see there, those new leaves coming out, that's still healthy. If you pull up this transplant, there'll be new roots starting. It'll be establishing itself. So it's completely fine. It's still going to make it, and it's healthy. It's just a normal process of celery managing the transplant stress. Stuff like lightning strikes. This is a picture I took. There's actually a what looks like an old flag sticking out of the ground there, which likely triggered the lightning strike. It's really important for scouts to know the weather and to get out of the field if they hear any thunder or lightning. A scout was actually in this field when the thunderstorm came through. The scout had just gotten back to their car on the road, probably 100 meters away, when this lightning strike hit. So we came back a day later and took pictures of it where it actually hit, and there was that flag there. But really important, don't mess around with thunderstorms, especially because you're likely the tallest thing in any field that you're going to be scouting. Hail damage, I've mentioned, pretty obvious. Shredded leaves, you'll see bruising, similar to something like pelting rain. In this case, this is early carrots that were subjected to a pelting rain. All the carrots are basically flattened against the ground. They likely come back, they'll pop back up, they'll continue growing. But it's possible that the damage caused by this pelting rain was so stressful that the taproot was actually disrupted. And it's possible that this entire field would be unmarketable, full of just forked and stunted carrots. So it's important to come back a week or two later and check the taproot in a bunch of spots to see if these carrots were negatively affected by pelting rain. And I would say the same thing applies to a frost event. Drainage is really important. That's why carrots are up on raised beds. Too much water early in the season leaches nitrogen and can also kill the plants due to the anaerobic conditions of being waterlogged. As I mentioned, that's why carrots are up on raised beds, to sort of kind of keep them away from any standing water or a high water table. Drainage is also important when it comes to transplants. So you may see weird things in a recently transplanted celery field that could be tied back to the watering in the greenhouse. So you see actually in this bottom picture, the plants on the edges of the trays are healthier than the plants on the inside of the trays. Why is that? Well, it's likely that the trays on the outside are drying out faster because they're exposed to that pathway. And they're actually healthier because these plants are being overwatered. So a lot of times, sometimes the transplant issues can be tied back to greenhouse management. Early season problems such as wind damage, same thing. You should know if there's been high winds in the area. Early season plants that do not have wind abatement crops, or even if they do, sometimes you'll see some significant wind damage and basically wind stripping, where it strips the cuticle away. Heat canker is a very common issue seen in carrots. Later seeded carrots, especially when it comes to June or late June, some of those later seeded carrot crops are just in their, bunny ear to first, second, third true leaf stage. And if you get a day about 30 degrees, especially in muck soils, the soil can heat up very hot, and it basically restricts and burns the carrot at the soil level so that it can't expand any further than that. So you'll see in that middle picture there, there's some canker at the top of the root and where it meets the leaves. That is a restriction that won't be able to grow any larger than that because it's basically scabbed over. So these carrots will not be able to fulfill their yield potential. Carrot forking, a lot of times it's Pythium and nematodes, what I mentioned also, it can be caused by a huge number of problems. Compaction in the area, too much water, not enough water, a pounding grain early in its growth stage, heat stress, wind damage, herbicide injury. All of these can play a part in stressing out and forking a carrot. So it's really important, especially that you rule out Pythium and nematodes because those can have long-term rotational effects. Bolting, if you remember that the crops in the Apiaceae family are biennial, so they're only supposed to flower the second year. But if you stress out the plant enough, a carrot or a celery plant with cold or heat, sometimes it actually triggers bolting in the first year. So that basically the root will become all hard and woody and knobby and very bitter. And it won't be marketable because it's producing a flower stalk because basically you stressed it out enough that it thinks it has to get out of there. Differences in day length as well. So if there's a new variety that's not adapted to our day length in the summer, it would also cause it to stress. You see that with different colored carrot varieties very often. Some of the red carrots and the yellow carrots aren't very well adapted to our day length. Celery bolting usually occurs if it's very cold temperatures. So any early transplanted celery fields that have been subjected to these cold temperatures the past weekend, you may see a higher incidence of bolting this summer. Carrot bolting as well. You see on the left there, those are a bunch of volunteer carrots. So this field was planted 2 years in a row with carrots, and a lot of the harvested carrots that fell through the harvester are flowering in the second year. Sometimes you'll see deer and rodent feeding damage. So you may pull up a clump of carrots and there'll be huge bite marks in them. That might be mice and field mice. And deer you can also see often in trails and pathways through the field where they'll trample all the tops and they'll stop to rip out a bunch of carrots and feed on them. Chimera is basically a genetic mutation which causes variegated plants. You can see this in a lot of plants, especially distinct in celery and onions. You can see here these examples. It's just a genetic mutation which causes a little bit of a yellowing discoloration, basically. Dodder is an interesting thing I've seen only a couple times. It's quite rare, but it's actually a parasitic plant. So it's a weed that's it's all these yellow vines, and it's actually attacking and sucking the nutrients out of these carrots at the top and onions at the bottom. So more of an interesting, growers will usually, if they see any dodder, they'll go in and rip it out because it can be quite devastating. But yeah, quite an interesting parasitic plant. Get a little bit into nutrient deficiencies now. In order to diagnose them, it's the easiest thing is just to take a soil test. Sometimes you can also diagnose it via plant symptoms, but some crops don't have very well established nutrient deficiencies. So it can be difficult to sometimes determine what the causes are and what the actual symptoms are. There's a lot of wives' tales in nutrient deficiencies that, you know, if you see this, that means that it's manganese deficiency, and if it does this, but none of these things have really, some of these things haven't been proven. So a quick refresher on macronutrients. So your NPK, nitrogen, phosphorus, potassium, are considered your macronutrients, really important. Secondary nutrients like calcium, magnesium, and sulfur, also very important, especially in terms of calcium on celery. You see a number of micronutrients there. Celery in particular really needs multiple applications of a number of micronutrients. So growers will be constantly foliar feeding typically celery on almost a weekly basis with especially some of these micronutrients, things like boron, which I'll get into in a little bit, and other nutrients as well. So I'm going to quickly skip through these slides. They're in your handouts for reference if you want to go back to them. They have sort of our nitrogen recommendations and other macronutrient recommendations that we've developed for carrots. Carrots can be sometimes difficult to see the nitrogen deficiencies. This is actually nitrogen trials. So you can see here, these are all different rates of nitrogen. You can see the plot in the bottom there in the middle. It looks smaller. The plants are a little bit more yellow, whereas the plot in the middle to the right near the road is lusher, it's greener. So on a field level, sometimes it might be difficult to identify, but especially if you have low-lying areas that have sat in water and the nitrogen is leached out, it's really easy to tell sort of where your deficiencies could be and link that to nitrogen. Those are our recommendations you can refer back to. Phosphorus typically shows up as purpling in the leaves. Oh, look at that animation. Those are our phosphorus recommendations, potassium recommendations for mineral and muck soils as well. Potassium deficiencies often are thought to have shown up as reddish discoloration, so reddish to purplish discoloration. As you've seen a couple times, it can often be confused with aster yellows in carrots. So if you see a reddish to purplish discoloration of the leaves, and you go check out that plant and there's no proliferation of shoots and there's no proliferation of roots, it could be a potassium deficiency as opposed to aster yellows. As I mentioned here, it's really important that you go in and see if there's any other symptoms of aster yellows when you see a red carrot leaf like that. Magnesium deficiencies typically show up, there it goes, as yellowing in between the veins. So kind of an interesting pattern develops. The veins look green in the potato leaf, but everything of the tissue in between the veins will start to turn yellow. That's thought to be a magnesium deficiency. Calcium deficiencies often show up as tip burns in various crops, and the same is true of celery. Calcium is a larger molecule. It really only moves with water, and even with water, it doesn't move that very well. So if we have a dry summer or a hot and dry, lots of variations in soil moisture, you'll often see calcium deficiency showing up because rapid growth without the ability of the plant to get the calcium from the soil to where the growing tips where it needs to be often results in tip burning. So in celery, we call that tip burning blackheart. So in the growing point of the plant, if you open up the stalks, you'll see that the growing point will start to brown, the tips will start to die off, and basically will start to rot. Secondary rots will come in, and basically the inner growing point will start to rot because the plant couldn't move calcium fast enough to the growing point where it needed to be. And so that's typical in hot weather. It's often also often misidentified with celery leaf curl. So a symptom of celery leaf curl is that the new growths inside also start to die off, they start to brown, and they start to rot. So if you see blackheart, it will not have any of celery leaf curl symptoms. Celery leaf curl symptoms are quite distinct. The top leaves will start to droop down. You'll be able to see that as you're walking through the field. There'll be markings on the petiole as well with celery leaf curl. And then you'll also later on see some rotting in the middle heart. If you see rotting without any of those other leaf curl symptoms, it's likely blackheart and a calcium deficiency. Manganese deficiency is similar to magnesium deficiency in that you see green veins and sort of yellowing interveinal. Growers are often foliar spraying manganese as well as part of their foliar feeding programs. And last one, I believe, is boron. Similar to calcium, boron doesn't move very well. Sometimes it can build up to toxic levels in rotational crops, so growers are also very wary of applying too much boron, but it causes what looks like cat scratching on the celery stalks. So if you see those markings there, they're lateral markings across the celery stalk. It looks like a cat came and used it as a scratching post. That's very typical of boron deficiencies where those petioles start to crack. So our predecessor, pathologist Mike Chicoletti, who recently retired, would always have this slide up. He'd recommend this disease and pest of vegetable crops in Canada. This book is no longer in print, but it is available online as a PDF. It's actually a amazing resource for any sort of diagnostic problems you may have. It basically has a great list and description of any diseases you're going to encounter, and it has a nice photo gallery in there as well. So if the PDF is free to download, it's a good reference to have. Whereas also a older reference that's still quite relevant available that we can give you a hard copy of if you're interested. Just follow us up with us afterwards, called Integrated Pest Management for Onions, Carrots, Celery, Lettuce in Ontario. And there's also compendiums available through the American Phytopathological Society for umbelliferous crops. They're great to have. They're not that expensive. You can order them online, and you can just fold them up and put them in your back pocket, which is nice to have in the field to reference for if you're seeing something you don't know what it is. Okay, with that, we are going to move on to our final quiz, where hopefully you learned something. And after that, please stay on, because we'll put up a quick survey on Fido that you can quickly fill out to give us some feedback on what we can improve on, and also some feedback that we can feed up to the people upstairs so that they can allow us to continue to have these workshops. So if you can pull out your cell phone again or whatever you're using and switch over to Slido, we'll run through the final survey again.
Right on. I think you figured it out. 10. There we go. What caused this? Astral yellows, carrot weevil, heat canker, pythium, root knot nematode, or root lesion nematode? Give people a few more seconds. 3, 2, 1.
So I love starting out with a hard one to start. I will accept root lesion nematode as well, because it does look exactly like root lesion nematode. This sample was actually taken from a spot with carrot pythium problem. So this is actually pythium attacking that taproot early on in the plant's development. So this will turn into what I showed you on the pythium stunting slide. So basically, this taproot will be killed. It will stunt. It'll start creating a whole bunch of lateral roots from there, and you'll create that weird forked carrot that you saw in those pictures because of this early season damage.
What disease is this? Alternaria, bacterial leaf blight, cercospora, powdery mildew, or white mold? Got those oval lesions on the stem? Five,
Couple
4,
more seconds.
3, 2, 1.
3.
Well done.
83%. Nice work.
What disease is this? Astral yellows, pythium, root lesion nematode, fusarium, violet root rot.
Couple more seconds. 3, 2, 1. So another hard one. This is actually cavity spot. So this is pythium. These elliptical lesions will start to turn darker. You see them on the right, and the bigger ones on the left. They'll start to turn darker the longer it goes on and look worse and worse. What is this? Alternaria, bacteria, leaf blight, violet root rot, powdery mildew, or white mold?
5, 4, 3, 2, 1. White mold is correct. All right, here we have a celery plant, cup downward leaves next to what looks to be a healthy plant. The black heart, calcium deficiency, celery leaf curl, cercospora, early blight, fusarium yellows, septoria, or sclerotinia. 5, 4, 3, 2, 1. 100%. Well done. What is this? Got these tan and gray lesions. Is it black heart, celery leaf curl, cercospora, fusarium yellows, or septoria? Five, 4, 3, 2, 1. So this is actually a trick question. You might have noticed you could pick multiple answers. It's both. We have both septoria, leaf blight, and cercospora, those tan lesions on the slide. All right, and our last and final question, what is this? Is it black heart, celery leaf curl, cercospora, fusarium yellows, septoria, or aster yellows? 5, 4, 3, 2, 1. 72% of you were correct. It is aster yellows. It looks a lot like fusarium yellows, and what you would do to make sure that it is not fusarium yellows would be to dig out that plant, do a cross section of the stalks, and see if you can see any discoloration in that vascular tissue. All right. With that, if you have any questions, feel free to submit them to the chat, whether it's on Zoom or Slido. I'd also like to thank our crew behind the scenes, Ashley, Josh, and Maria. They have helped us out a lot putting on these workshops, so thank you. And I'd also like to have, if you haven't done so already, be sure to subscribe to our On Vegetables blog. It would be awesome if you could fill out the survey before you leave. And like Dennis said, this really helps us to improve future workshops.
Yeah, responses are anonymous. I don't want or care who you are. Just be honest in your feedback. That'd be great.
Thank you.
Thanks, everyone. Bye for now.